Ladies and gentlemen, please join me in welcoming to the stage your MC for Reactathon.
Mentions, and it's a beautiful thing. And we have friends dialing into the live stream as well. Welcome to Reactathon in the Park. My name is Anjana Vakil. I'm going to be your MC for the next couple of days. So excited and grateful to be here with all of you in this beautiful spot that we find ourselves in. Just really excited that we are able to be back in person. So here we are at Reactathon in the Park. We find ourselves in the gorgeous Brun Amphitheater. Cal Shakes is hosting us. Thank you so much, Cal Shakes, for having us. And if folks want to have an event in a beautiful venue like this, please go talk to John and Kyle at the Cal Shakes booth on your way out of the venue. Because, yeah, how great is it to be in this gorgeous setting? Am I right? Give it up for California and Cal Shakes. Exactly. And we do just want to, like Cal Shakes, acknowledge that we are having this gathering on ancestral and unceded lands of the Bay Miwok people and the Chochenyo-speaking Ohlone people, and that these lands were taken and colonized violently. So please, if you want to support the community in contributing to the Ohlone community's work on making this a vibrant future in this beautiful place for generations to come, check out the links on calshakes.org. So thank you so much to Cal Shakes for having us here. Thank you so much also to our sponsors for making this possible for us to gather here today. Our presenting sponsor this year is Vercel. Woohoo! Give it up for Vercel! Vercel in the house! Excellent. Love it. So as you all probably know, Vercel is out there making the web faster, providing the toolkit that front-end devs love, and unlocking developer potential, enabling anyone, including us, to build the future of the web. So Vercel are the creators of the React framework Next.js, hey, and other popular open source libraries. They got the Turbo repo, they got the Webpack, they got the SWR, they got the SWC, and lots more. So please be sure to stop by the Vercel booth, and we're going to be hearing from some members of the Vercel team tonight. Get excited! All righty. And also, please get excited for our platinum sponsor. I'm going to try not to be too biased because I am a senior developer advocate there, but our platinum sponsor is Hasura. So Hasura, woohoo, yeah. Hasura, we make instant GraphQL for your new or existing applications. You can connect to your databases, to other APIs, REST or GraphQL. We accept all kinds. And get an instant, real-time, unified GraphQL API going. And it's a pretty nice experience. I think I love it as a developer. I don't know about y'all, but you give us some love. Stop by the booth. Check out hasura.io. And yeah, open source, requires no upfront GraphQL knowledge. Take it from me. So if you have any questions, come talk to us at the booth. Awesome. So thank you so much to our sponsors for making it possible for us to be here. We are honored to be able to gather, some of us, safely in person. It's been a rough couple of years, am I right? Can we give it up for ourselves for getting through them? Thank you. Yes. Okay. And just really happy to be back in person. And again, we're trying to gather as safely as possible, so please be respectful of each other. Really looking forward to all these amazing conversations we have already been having, are going to keep having. And while we are having those conversations, let's keep in mind a few points of housekeeping. First and foremost, code of conduct. We follow it, we read it, we abide by it, we love it. It's at reactathon.com/conduct. Please give it a look, and if you have any issues, please come talk to a Reactathon staffer in the yellow shirts. And yeah, let's just be good to each other, huh? So another thing that we should keep in mind to be good to each other, raise your hand if you heard of the Pac-Man rule. Okay, a few folks. All right, great. You all already know. For the folks that don't, Pac-Man rule is when you're at a conference, you're standing in a circle having a really interesting conversation, but someone new can't really get in because there's no room unless you turn that circle into a Pac-Man and leave a spot that someone can walk into. So try to keep that in mind. Try to leave a spot open for new friends to come and get involved in your super awesome nerdy conversations. Alrighty, a couple more things to know. You've probably already discovered we have not one, but two groves at this venue. There is the upper grove, which you will find behind you, which is we're going to have food, we're going to have drinks, silver sponsors, respite tent. That is where you can find extra sunscreen because you forgot yours, extra Tylenol because I'm talking too loud, extra hand sanitizer because you want to stay clean and healthy. So you can find all that in the upper grove. And then in the lower grove, the picnic table areas, you can lounge, you can eat your meals, you can chill, you can enjoy the beautiful nature and enjoy these awesome conversations we get to have in person with each other. And speaking of the beautiful nature in which we're having all these conversations, sometimes it throws unexpected things our way. I'm talking about wasps, not the kind that summer in the Hamptons, but the kind that might sting you if you are too aggressive with them. So please, if a wasp lands on your table or lands near your food, don't swat it away, don't kill it, because it will make the others more aggressive, apparently. Fun wasp facts that we're learning. So instead, just lightly urge it to move on and find another area, and if possible, make it a peace offering in the form of a piece of meat or something like that that you throw way in the corner so it goes over there and not on you. Let's not get stung by wasps. I don't know. All right, so now that we've learned all we need to know about wasps, let's talk about prizes. Yay! We're at a conference. That means you know there's going to be contests, you know there's going to be prizes, and I'm not going to tell you what it is. It's a secret, but there's a secret prize that you can find out by winning the contest. How do you enter, Anjana, you may ask? Well, tonight we are going to have a challenge that is photography-based. So your challenge is to take 3 photos. One with the Reactathon logo, one with the Vercel booth, and one with the Hasura booth. Then you take all those 3 photos, you put them in a tweet, and you tag Reactathon, and we will select the winners tonight and announce them tomorrow morning. Super secret prize, super secret winners. Get out your cameras. This is your moment to shine. All right, awesome. So that is all of our housekeeping points. We are going to move, it keeps going, but tonight we have our first keynote speaker who's going to be kicking things off with a talk on the state of React. Please join me in giving a very warm welcome to Lee Robinson from Vercel. Hey!
Wow, this venue is amazing. I love it so much. I love it so much. Hey everyone, welcome to Reactathon. I'm so excited that we're all here in person, getting to meet again and see some old faces, some new faces. It's gonna be a really fun couple days, so I'm excited and really honored to be able to kick things off tonight. Tonight I'm gonna be talking about really where React is at today and where it's headed in the future. So I'm Lee, I'm the Director of Developer Relations at Vercel. And has anybody here used Vercel before? Show of hands, a few? Wow, amazing, I love that. Okay, I'm glad there's some people who have used Vercel. If you haven't, Vercel is a platform for basically making fast websites. And we're also the creators of a React framework called Next.js. So at Vercel, I lead our community and education efforts. I spend a lot of time talking to developers about how to build with React and how to build fast websites and great user experiences. So as you also heard, Vercel is the presenting sponsor today. Come check out our booth and talk to the Vercel team. We'd love to show you around the product and help you out with your next apps. So learning and investing in React was the best thing I've done in my career. Seriously, it's helped me become a better web developer, land multiple jobs, and connect with so many amazing people in the community like you all. So for the next 20 minutes here today, I want to talk about the state of React, kind of where it's at today, where it's headed, and why you should get really excited about the future of React. So let's start off by talking about you. Yes, all of you in the crowd here today, whether you're new, experienced, aspirational, seasoned React developers, I want to talk about a parallel between architects, like building architects, and developers. I found a lot of parallels between these two in my career, and I think it makes for a fun analogy. So just entertain me here today as we consider this analogy. So a React developer often takes list of requirements and constraints and uses them to design a solution using some tools that they're familiar with. Okay. So does an architect. They take some tools, they design a solution, and they use some tools that they're proficient with. Kind of see where I'm going with this. So let's imagine that you're all architects, right? You've just completed your training and your education, and you're ready to design this new world to craft it more beautiful than before. I won't go into it too far. Maybe even something like this, you know, just a quick drive away from where we're at here today in Berkeley, California. But to design this solution and to build this world, you need tools. And the same goes for developers. And today, when building for the web, many developers are choosing to build with React. So I want to talk about why React. Why did React become so popular? And it might sound strange, given we're all here today, right, at a React conference, but I think it's helpful to recap how one small open source library created in 2013 has led to, you know, hundreds of new friends here together today at Reactathon. You know, we love a good meme here. React enables developers to build great user interfaces. The original goal of the library still holds true today, providing these primitives and these patterns for architecting great web experiences. It provides the blueprint. Another architecture reference. React made building with components accessible to everyone. And when developers think about React, they think in components. One of my absolute favorite parts about the React documentation is the piece called Thinking in React. This really helped me understand the mental model to deconstruct user interfaces and to think in kind of the component-based building blocks. React succeeded, though, not just because of the software or because of the product. It succeeded because of the community. There's millions of React developers, thousands of React libraries. Some of you even work on those libraries. And a wonderful community really helping educate and train the next generation of web developers and React developers. That is why React is one of the most popular ways of building for the web today. And React has been evolving. Well, it stayed true to building great user interfaces. That's the core of what React does. You might have noticed a shift in how developers are actually using React today. If we look at React in 2022, you'll see that there's a bunch of frameworks built on top of React that abstract things like routing or rendering or data fetching to try to provide a great developer experience and simplify this process for development teams. There's design tools that compile to React. You can drag and drop in a visual editor and move around components that are actually hooked up to real React components. This is Plasmic. There's visual editors for interactive content that allow you to seamlessly merge your React, your JSX, your components with your content, whether that's Markdown or some remote location. There's even variants of React that run on every type of device. You want to make a 3D game in the browser? You want to make a mobile app? You absolutely can. Yeah, Expo. We love Expo. React has delivered on providing excellent tools to developers. And while the type of applications that we might have built at the start were pretty small, they've really grown to enable React developers to build anything they can imagine on the web. I think that's really powerful. But it's not just React that's evolving either. The web is drastically different today than at the start of React or even just a few years ago. First, the global adoption of smartphones is growing more and more every year, with the majority of the world just seconds away from a web browser. And that has a lot of implications because that web browser is the largest app store in the world. Anyone can put content on the web in seconds and share it with a global audience. This democratization of the internet has really created this vibrant world where you can build incredible web experiences that would have previously required specialized hardware. And finally, it's not just a single browser. All browsers have been working together better than ever with cross-browser support at an all-time high. So whether it's things like CSS Grid or Flexbox or lazy loaded images, all these things are now available in all your major browsers, which means less polyfills and less JavaScript that you need to ship to your visitors. And it's still getting better yet. This is a project called Interop 2022 between some of the major browser vendors that's working really closely together on shipping impactful features across all browsers. This is going to be great. I know as a web developer, as a React developer, the less that I have to think about targeting one specific browser and the more cross-browser adoption we have, the better. So let's just quickly recap. React is really popular, right? And it's evolving with the web to support this global audience and work seamlessly across all the different browsers. So does that mean that it's easy to build a React application today? If we go back to that blueprint that React gave us, it's clear what the end goal and the outcome is here, right? We want to build our skyscraper. But the steps between blueprint and skyscraper, you might be confused about, or you might leave a little to be desired. If we really lean into that architecture analogy, right? How would we build a foundation that's resistant to strong winds? What type of materials would we use based on the environment? What would we do about our supply chain? Like, we could go really far into that analogy. I'll save you there. But when we look at the web today, we see that while it might seem simple on the surface, a lot of developers are actually faced with what I like to call the iceberg of the web. There's a lot more than meets the eye. And React is incredibly powerful, but this iceberg of complexity, things like images and fonts and scripts and internationalization, React has historically been less prescriptive about the solutions for some of these things and has kind of delegated this to the community, whether it's libraries or frameworks, to come up with solutions to some of these things. And I think this is a blessing and a curse. So it's great that you can npm install React basically anything and get it working in your application right away. But as React has grown to be one of the most popular ways of building online today, the community, I feel, is really looking for stronger suggestions and deeper integration into the tools that they're using. So React is evolving for the future, and I want to talk a little bit about that today. There's a lot of hard parts to building user interfaces, and I like to think about React now as a collection of solutions to those problems. Architecture primitives for building user interfaces. I think that's really powerful. The architect analogy here, developers and architects still have these fundamental building blocks that they use to create their structures. Maybe for an architect, it's the materials we're seeing, and maybe for a developer, it's your components, right? But the type of problems that React developers are looking to solve are requiring more advanced tools and more strong suggestions, like I mentioned. So I want to talk about a few web architecture problems for building great user interfaces, and then talk about how React and the future of React is helping solve these. So first, I want to show the most relevant content immediately without waiting for JavaScript. Okay? Secondly, I want to instantly respond to user input. Okay? And third, I want to navigate between different screens in my application without blocking any user input. Now, notice that I didn't say components, I didn't say JSX, I didn't say React anywhere in here. There's nothing React specific. These are just good problems of building user interfaces at scale. So how is React evolving to help solve problems like this? Let's first talk about showing the most relevant content and using streaming server rendering using suspense. We've heard of suspense before, hopefully. We want to show HTML to our visitors instantly before any of our JavaScript files have loaded. Now, previously, solutions that were your own custom server rendering environment or using a framework, they're essentially all or nothing. Either you have all of your HTML or none of it. And if I'm loading this form component in the right here, if that required fetching data from some API and it was slow, we're essentially as slow as our slowest component. So it would block rendering until all this content was shown. With improvements in React 18, we can show this interface immediately and then stream in content updates as they're available. So we can suspend or pause rendering while we're waiting on our form component to load using suspense on the server. Suspense is a concurrent feature of React, and it lets you write asynchronous code as if it was synchronous. So let's look at how that can enable us to instantly respond to user input. While we're in the middle of rendering this suspended component of the form, we can still interact with the rest of the page and not block the main thread, thanks to React 18. So to create this amazing experience, React has essentially re-architected itself in the past 2 major versions to deeply support asynchronous code and scheduling. And concurrent features like suspense are really opt-in and available only as you use them. Now notice I said concurrent features and not concurrent mode, and that's because React 18 is really embracing this incremental adoption strategy and allowing you to, instead of having a app level toggle, it's only as you use the features. So I love that. I think that's amazing. I'm very excited for that. So React 18 is giving us primitives for these solutions, for building these great user interfaces, and then frameworks can take these and deeply integrate them into their router, into their data fetching layer, into their server rendering environment, and help solve that all or nothing data fetching problem I was talking about, and give a really great developer experience when using asynchronous code. I'm personally extremely excited about this, and I think the future of React is going to be amazing. The last one I want to talk about is navigating without having to block any user input. We want our server rendered applications to really feel like an app. And when navigating between routes, the user shouldn't be blocked from interacting with that interface. So with React 18, we have some new features that allow us to tell React which parts of the interface are urgent. So if more urgent things come in, like clicks or key presses, we can prioritize the most important work. These new features are pretty amazing. And I'm excited to share here today at Reactathon that Next.js is releasing a new routing system that takes full advantage of React 18. Woo! This new Next.js router supports nested layouts and nested routes, the ability to fetch data in layouts, and it's the first router that's designed for server components. And the best part is that it's 100% incrementally adoptable. You'll be able to use this router for complex dashboard layouts, advanced modal routing, and way more. I'm incredibly excited about this. This is something that I know people here who've been using Next.js have been looking for a long time. But you'll hear more about this from me in the future. I just wanted to share a quick update with my React friends here today at Reactathon. So let's go back to everyone here for you, and what does this mean for me, the architect, the developer? Whether you're building a small blog with React, my site right there, or some of the largest sites in the world, React is built to grow with you. React is your reliable toolkit. These tools have stood the test of time. They're valuable, purposeful, and they're well designed. And the future of React gives you new tools that you can incrementally adopt into your toolkit. Frameworks simplify this experience, allowing you to build bigger and taller buildings. But the fundamental building blocks and the architecture of React remains the same. So in summary, React is your blueprint of architecture primitives for building user interfaces. New React features are tools that you can incrementally adopt into your workflow. Frameworks give you an opinionated tool to build a strong foundation, allowing you to scale your skyscraper to the tallest of heights. And the summary of these allows you to craft really great user experiences. I hope that you're as excited about the future of React as I am. Thank you so much. Awesome. Cool.
All right, everyone, please keep it going for Lee. Hey, yeah. And please join me, without further ado, in welcoming our next keynote speaker to the stage from Remix. Please welcome the amazing Kenzie Dodds. Hey! Tiny one. Okay.
Did it go good?
Yeah.
Okay.
Yeah.
Hear myself. Can you hear me? Okay, now I can hear myself. Great. My name is Kenzie Dodds. I'm a software engineer from Utah. I work at Remix. I'm the director of developer experience. You might have read one of my blogs, blog posts, or listened to a podcast on kenziedodds.com. And then I also created epicreact.dev and testingjavascript.com. Anybody use those before? That's nice, thank you. For the rest of you, those are actually on sale right now. So if you wanted to go get those, then you can. And ask one of the people to raise their hands if it's worth it. I'm going to be talking about the edge. And so first I want to talk about what the edge even is. So we're going to do a little bit of a history lesson on building for the web. Oh my gosh, I'm seeing like friends of mine, and I'm like really tempted to wave at them and call them out, but sorry. I'll give you a hug later. So the way that we build for the web is we have a client and we have a server. And the server has some information the client wants, so the client says, hey, server, I want to get that information. In our world, in the world of the web, we're getting HTML documents. And so wherever we are in the world, we need to connect to the internet, and through this series of tubes of infrastructure, get to that server. And then the server says, oh, I know who you are. Let me generate some HTML for you, and I'll send that right back to you. And now you can view it on the screen. And that works out great, except that users, wherever they are in the world, need to go talk to that same server. And the series of tubes that they go through can make that take an exceedingly long amount of time, and it reduces the user experience because the performance is so bad. So, but the problem is, like, we need to talk to the server. Like, the server has the information that we need, right? So we found out that some of the information that the user needs is has nothing to do with the user specifically. It's the same for everybody. So that's like your images and your CSS and your JavaScript. And so we created a content delivery network, or CDN, that can hold all those files. So we just copy paste those on all of these different servers all over the world, and then the user can at least get those static files wherever they are in the world, and so at least that piece can be faster. But they still have to go and get their data and get the HTML for server rendering from that server. And so the way that this works architecturally is you've got the user. They are requesting a document that'll go to the server. That generates the document, sends it back to the browser, and then at that time the browser knows, oh, there are some like link tags and image tags, and there's JavaScript script tags and things. So let me go get those static assets. We get that from the CDN. So the edge, there are a couple different implementations, but many of the implementations are coming from the CDN space. Those who are involved or who have these servers all over the world, they thought, hey, now hold on a second. We solved the static problem by putting all those static files, copy-pasting them all over our network. What if we just made it so that the users of our network, like the developers, us folks, what if we made it so that we could, they could send some scripts that they could run to like maybe dynamically generate HTML, for example. And so that's what many of these have done. They say, okay, now we've got this CDN of all these computers all over the world. We're going to let you upload a file, and now you can run some code and dynamically handle these requests. And so now you can know who it was that's making the request. You can dynamically generate the HTML for that specific user. And the benefit of this is that because the CDN has got servers all over the place, the user can go to the closest server to them, as far as like geolocation is concerned, and make that request a lot faster. So that's basically what the edge is. And there are various implementations of this. There are various people or companies that have implemented this. So fly.io is where I host my website, and that was my first exposure to the edge. And the way that they work is they actually have, they ship your Docker container in any region that you want. So I've got a node server in my Docker container. They put it in regions all over the world, and so it's like a full server. Cloudflare and Fastly and Akamai are CDNs, and they said, hey, we've got these servers all over. Let's let people run code on those servers. And they have their various different APIs for that. And then Dino Deploy in the bottom right there is similar to Fly, except they're running Dino. And then Lambda at Edge is like a serverless platform, but at the edge. So it's regionless. It's pretty cool. So there are a lot of other companies involved in this. You have your data at the edge. One of our sponsors, FaunaDB, is doing data at the edge. And then you also have other companies like Netlify and Vercel that are wrapping some of these services. So lots of people getting into the edge game, and it's really cool. So with this new capability, how do we take advantage of it the best that we can? And there are a lot of approaches to this. I'm the director of developer experience at Remix, so obviously I'm going to be talking about how Remix takes advantage of these skills and abilities. And the first thing that I want to talk about with, oh, and by the way, if you don't know what Remix is, it's basically like V7 of React Router. It's like an upgrade of React Router that supports server rendering. It's a compiler. And it's just amazing. I loved it so much that I stopped doing my full-time teaching thing so I could just talk about Remix all the time. And if you follow me on Twitter, you know that I tweet about two things, Remix and Wordle. And so yes, I'm super excited about Remix, and so I want to tell you a couple of things that Remix does on the edge. So first of all, Remix normalizes the edge. Those different providers have different APIs for the request response that they're handling for us. And one of them, in particular, Cloudflare Workers, inspired the way that Remix approached this problem by implementing basically the service worker spec. And so their request response API is the web fetch API. And with Fly, you can deploy like a Docker container, so you can literally do whatever. I use Express, and so Express has its own request response thing. Dino actually also uses the web fetch API that's exposed on their servers. Node, in fact, is going to have the web fetch API, or I think it does in 18. And then Akamai has its own API. So there are a lot of different APIs. And I see Remix as kind of the jQuery for these platforms, because it normalizes all of the platforms to the web standard. And so what that gives you is that the more time you spend working on Remix, the better you get at the web platform, because that's the mental model that you're working with. Those are the APIs that you're working with. And so this is an example of a part of a route module in Remix. We have the loader and an action. The loader handles GET request. The action handles all the others for data specifically. And so that request object that you get is a web fetch request. And so if you don't like the request.headers.get with the string thing, blame the web platform. That's not our API. I actually think it's fine. And then that response that you send is like a web fetch response. And then on the action side, request.formData is a thing. I did not know this. Raise your hand if you already knew that request.formData was a thing. Wow. See, you knew more than I did when before I started using Remix. So, like the browser APIs already have affordances for handling all of these kinds of things. And so Remix, rather than wrapping it with our own idea of what request response is, we expose that to you so that you can just use the web platform APIs. I think this is something that the Edge is doing, where lots of those providers are moving us to just a standard API for request response. The next thing I want to talk about is how Remix moves code to the edge. So let's take a theoretical scenario where you've got your server is deployed to, like before Edge, so you've got a server deployed to Washington, D.C., and a user in Hong Kong, and they're coming all the way around the world to come get your HTML, and you're like, this is no good. And you decide, hey, you know what I'm going to do is I'm going to use FaunaDB, for example, or DynamoDB or something that is available all over the world so that my users can get their data really fast. Well, because you're located in Washington, D.C., the users have to go all the way around the world to go generate that HTML document, and that's going to talk to the Washington, D.C., and then it'll come all the way back. And this is not great. And so what you can do is you just say, well, I'll just client-side render everything, and I'll have the client do all the data fetching. So we'll take all of this code, we'll move it over to the client, and as client-side rendered thing, and then have the client be making the request, and they can just request it from whatever database is closest to them. So now we're on the edge for our data. Still, if you want a server render, you still are going to Washington for the initial shell, but that's a little bit better. But what we can do with the edge, though, is instead of taking all of that code and putting it in the client, we can actually just take the server code, leave it on the server, but bring it over to the edge server that's close to them. And so what that means is that we ship less code to the browser, so we can still keep that loader and action on the server. So all of that stuff, like if you're using GraphQL, you don't need the GraphQL client, you can leave that on the server. Whatever you're using to fetch data can happen on the server, but it can be geolocated very close to where the user's at. And so when they're making their request, it goes straight to the edge server that's close by them, and because that is running there, it can talk to the FaunaDB that's close to that. So you're just like in this little region, and it can be really, really fast, and you end up shipping less JavaScript. So that's another thing that the edge can do for us, and that's the way that Remix operates. The next thing is progressive enhancement. So this is a really cool thing that we have on the web. Is the browsers actually, fun fact, they know how to do links. They know how to do mutations. You don't need a router or anything like that. Like they know how to do all of this stuff. And so if you can design a framework that operates or emulates that sort of experience, then you can utilize progressive enhancement. So this is what I mean. In lots of the websites that we're building with React, we first have to download the document, and that's going to have script tags for our bundles and whatnot. So then we're going to go download our JavaScript. We're going to execute all of that and hydrate and whatnot. And now the app is ready, and we can start linking to different things. We can have our mutations all happen, on submit, event, prevent, default, all that stuff. So with progressive enhancement, though, if you can make the HTML that you server render and send to your user render like regular forms, and then like that the browser can understand, then you can move to something more like this, where you download the document, and then the app is ready. You don't need the JavaScript for the app to work. And that's because the browser knows how to do that stuff. So if you can make it so that your app works before the JavaScript loads, then the entire experience is better for the user. It's really, really, really fast. And then you still do download the JavaScript because it makes the experience better. Rather than doing full page refreshes when you submit a form, it can just do the regular fetch post request. And so what you get when the JavaScript is finished downloading is an enhanced experience. And so what we're talking about here is the difference between an JavaScript enabling the experience and JavaScript enhancing the experience. And you want to start with a baseline of a functional site that JavaScript makes better. And what we've done a lot is just kind of thrown progressive enhancement out the window and said, our baseline is our app doesn't work until the JavaScript finishes loading, which I don't think is good. And in fact, there are a lot of websites that we build today that don't need JavaScript at all. And so if you can make your web framework work that is progressively enhanced, then you can say, you know what, I don't think I even need JavaScript on this login page. Like, I want this login page to load like this, like super, super fast. I don't need to even bother with code splitting and all of that stuff. It's just like there's no need for JavaScript on this page. So we'll just not do JavaScript. The form will do what the form does, and then when that post is submitted to the server, then server can handle it, send them to where they need to go, and now we can have JavaScript because it's like a super fancy experience. We're building Figma or something like that. So that is progressive enhancement on the edge, making the entire experience that is ultra fast even faster, because the edge allows us to move code off, and Remix allows us to move code off of the browser into the edge, and then we can actually not even need the JavaScript that's left for the app to start functioning right from the get-go. Okay, and then the last one is Remix streams from the edge. So as soon as React 18 came out with streaming, we were really excited. It's awesome because what happens now is the request comes in, and before streaming, we'd have to like generate our HTML, render to string, and then we send it all back. And we can actually start, and the problem with that is if you have data that takes a long time, like you're making a request to your database to go get the user stuff or whatever, if that query takes a long time, then you can't send anything back until that string of HTML is ready. And so with streaming, you can actually say, hey, let's go ahead and start sending a response back so that the user gets something really, really fast, and then we can fill things in later. And this is a really, really awesome feature of React 18. And I'm really excited for you all to see Ryan's talk tomorrow because it is going to blow your minds. And I'm sorry, Ryan, for stealing a little bit of your thunder there, but it's going to be sick. Do not miss his talk because streaming and Remix are like just amazing. So, so cool. OK, so just to wrap up, this is the future, and it's so awesome. It is really, really cool. I fully expect that lots of us will be building applications with this type of architecture in the future. I don't think that it's necessary for every use case, but I think that the providers that I mentioned, as well as others who are in this space, are making this type of thing just as simple and straightforward as Netlify made for me when I started deploying client-side apps, where I just like, okay, connect this GitHub thing, and boom, now it's there. And it's magic, and I don't know how it works, but it's nice and fast, and I don't have to manage it. It's amazing. And these providers, and Netlify is in the edge game too, and Vercel and these other companies, making it really easy to get all of these performance wins without having to worry about servers. And it's also like outrageously cost-effective as well. It's also kind of rough. So as you like are getting into this, remember that this is the edge, and it is the bleeding edge. And when you're on the bleeding edge, you're the one that's bleeding. So that's a joke I heard from Ryan once, and it always gets chuckles. But it's true. It's true. You are the one dealing with all the fact that this is the leading edge here. but it's pretty sharp. It's pretty cool. The present is still cool. So if you're sitting here like, oh my gosh, I just like am barely trying to figure out how to do the thing that I'm doing, and now all of a sudden I'm being told that I'm doing it wrong. You know what? You're not. It's fine. Like most of the web is built on WordPress anyway. So not to like disparage WordPress. It like clearly it's working, right? But like you're cool. It's fine. I just want to give you an idea of what to look forward to, because these solve a lot of really cool, like interesting problems that you're probably experiencing. So the present is still cool. Don't feel like you're like being left behind or anything. This isn't the, if you don't learn this, you'll never amount to anything. Whatever. It's not that at all. And that's everything I wanted to share with you about the Edge. I think it is really, really awesome. I'm looking forward to what the Edge has to offer for us. And just one last thing I want to say. You're a fantastic person. Thank you.
Keep it going, y'all. Keep it going for Kent. Thank you so much, Kent. All right. Who's ready for our last keynote presentation of the evening? Yeah. Yeah, me too. All right. So please join me in giving a very warm welcome to the stage our final keynote speaker, who's going to be talking to us about advanced rendering patterns. Please welcome from Vercel, Lydia Hallie.
Hello everyone, good evening. My name is Lydia Hallie. I'm a staff developer advocate at Vercel, and I'm here today to talk about rendering patterns. Building on the web has never been more powerful than it is in 2022, but it can feel pretty overwhelming as developers to know which rendering pattern really makes the most sense for my application. In most cases, we just want to develop, preview, ship, have a great idea, share it with the world, but in most cases, it doesn't quite end up that way. Quick question, I don't have my notes here. Doesn't matter. But unfortunately, in most cases, we end up with really long build times and frustrated users because our website loads data really slow. And we might even end up with really high server costs or for a website that most people didn't even know existed because the performance was so bad, the SEO was so bad, so people didn't ever discover it. So although our idea might have changed our world, just the way that we architected our website prevented this from ever happening. So what can we do about this? We have to start implementing the right rendering patterns. Knowing how to apply these techniques can massively improve your app's performance, giving you a great product to share with the world. Now, usually when we talk about web performance, we talk about optimizing for the core web vitals. And these are a set of really useful measurements that tell us how well our site performs. For example, the time to first byte tells us how quickly our server responds with the initial data to make sure that our users don't stare at like a blank screen for too long. And the first contentful paint tells us how quickly our users are able to see the first contentful content. Now, I won't go over all of these right now. You can probably read it. But if we want to have a website with a great SEO, we have to start caring about optimizing for these core web vitals. But that's not all, because we also want to have the best developer experience. We want a project with really short build times in order to be able to iterate quickly. We want to have low server costs so we don't go bankrupt after a week of just having our project. And we want to show dynamic content in a performant way and just generally don't really run into any scalability issues once our website actually goes viral. Now, although this may seem like a lot to keep in mind, using the right rendering technique can really help you out there to create a great user and developer experience. All right, so now that we know why rendering techniques are so important, how do you know which one makes the most sense for your website? Or even if you deploy to Vercel, you can do this on a per-page basis. So which one makes the most sense for that page? Spending 1 minute on Google or on Tech Twitter can already feel pretty overwhelming with all the terms and abbreviations and latest trendy ways to render data, and especially people's opinion on them. Now, all patterns out there have their use cases, and there isn't really one pattern that's better than the others. They all have their trade-offs. So in this talk, I'll just walk you through some of the most common ones. To make it simple, I will just show the functionality based on Vercel's deployment, but it applies to everyone. All right, so first, let's talk about a pattern that may seem very basic and straightforward, namely static rendering. Static rendering is a very performant pattern because it comes with so many performance benefits. With static rendering, the entire HTML gets generated at build time. And these static assets are easily cacheable by a CDN or on Vercel by the Edge network. So this makes it possible to get extremely fast responses because we can just return the cache data from the CDN instead of going all the way to the origin server. Now, although it might seem simple, there are many variations to static rendering to serve a lot of different use cases, and we'll go through all of them. So first up is plain static rendering. Now, I'm using plain static rendering just because I didn't really know a better term, but we can use plain static rendering for pages that are really not dynamic at all. An example is this landing page for this demo real estate website. This page is absolutely perfect for static rendering because it just shows the same data for everyone globally. We aren't fetching any data or showing any personalized components. So when we deploy this, in this case to Vercel, the HTML gets generated for all the pages and eventually persisted to static storage. Now when a user visits the website, a request is made to the server, which can quickly return the pre-generated HTML. And as it does this, the edge location closest to the user actually caches the response. Now the browser renders the HTML and optionally requests another JavaScript bundle in order to actually hydrate these components. And hydration is just binding the event handlers to the HTML in order to make them interactive. So from a performance perspective, this is a great approach because we can have a really quick time to first byte as the server already contains the pre-generated HTML, and the browser can quickly render something to this screen, resulting in a really fast first contentful paint and largest contentful paint. And also we don't have to worry about layout shift because the pre-generated HTML already contains all the components. So we aren't like dynamically rendering any components as the user is requesting it. So plain static generation is great for your core web vitals, but in most cases we probably want to show some dynamic data, saying that instead of like just showing the features, we actually want to show the recent listings. Now, we could just hardcode the data right in the page, but in most cases, we probably want to use a data provider to fetch the data from. One approach we can take here is to use static rendering in combination with client-side fetching. And this is usually a great pattern for pages that contain data that should like renew on every request. We can simply statically render the website like we did before and fetch the data with, for example, using SWR on the clients, like as soon as the page is loaded, and as it's doing that, we'll show a skeleton component or skeleton UI. Now we do need to create like a custom API route to fetch the data from, for example, the database or another data provider and call this API route on the client. Now when a user requests the page, the server again returns with the pre-generated HTML, and the user initially sees a skeleton UI since the data hasn't been fetched yet. Now, after parsing and rendering the content, the client fetches the data from the API routes, after which we can actually see the listings. So although static rendering and client-side fetching gives us, again, a really good time to first byte and first contentful paint, the largest contentful paint kind of suffers because we can only show the listings once the API route has actually responded with data, after which we can render the listings. Now, we may also run into layout shifts, and this can happen if either we're lazy and we're not showing a skeleton component at all, or the skeleton component doesn't like have the same height and width as the component that eventually gets rendered. Also, since we're calling the API route on every page load, we may end up with really high server costs. Now, when you use Next.js, you can actually choose between a few more static approaches that really improve the performance of your app when you're using static pages in combination with dynamic data. One of them is with the getStaticProps method. Now, this method runs server-side at build time, meaning that we can directly call our data provider within this method. This can be like a really good solution if you have dynamic data for pages and the data is already available to you at build time. Now, the getStaticProps method runs server-side, so we no longer have to deal with having those custom API routes to fetch the data from. And we also no longer have to show that skeleton component because there will never be a loading state because the generated HTML already contains that fetched data. Now, when we build the product, the data provider gets called and the return data gets passed to the HTML. So now when we request the page again, the server can quickly respond with the pre-generated HTML. It gets cached, rendered to the screen, and the browser can send a request to optionally hydrate it. So from a user perspective, it's pretty similar to what we did before with just static rendering without having that dynamic data. But from a developer perspective, we can quickly run into some issues. Imagine pre-building hundreds or thousands of pages using that getStaticProp method, which can easily happen if we have an e-commerce website or a blog. And if you want to execute that during your build and it takes maybe half a second to fetch that data, you can easily run into really long build times. And if you're using an external API that maybe charges for every request, you might also end up with really high costs for that third party. And another issue is that we're only renewing that data at build time, meaning that we'd have to redeploy the website every time to update the content. Now, luckily, we can use incremental static regeneration to solve our build time with the dynamic data issues. Because with ISR, we can decide to only pre-render certain pages and render the rest on demand when a user actually requests it. Now, this can result in much shorter build times. It also allows us to automatically invalidate the cache and regenerate the page after a certain interval. Now, imagine if we wanted to show individual listings as well and pre-render these pages to get a great performance when a user clicks on a listing. Using Next.js, we can have those dynamic paths in combination with the getStaticPaths method to tell Next which pages to pre-render and which pages should be generated on demand. Now, in this example, we're actually fetching all of the listings, so we're actually pre-rendering every single one of them. This could easily end up in really long build times. Instead, we can tell Next to only pre-render a subset of all the pages and then use or render a fallback while the other list or the other page is generated on demand. Now, the pre-render pages behave the exact same as we saw before, but if a user requests a page that hasn't been generated yet, the generation or the page gets generated on demand, but eventually also cached by the edge. So this means that only the first user within a certain region might have a worse time to first byte, but everyone else just gets the cached response, so they get a good time to first byte. All right, so now our long build times have been solved, but we still don't want to have to redeploy the page every time to renew the data. So instead of only renewing the data at build time, we can automatically invalidate the cache and regenerate the page in the background on a certain interval. And we can do this by adding the revalidate field to the returned object by getStaticProps. So now when a user requests a still page, meaning a page that has been cached for longer than the number of seconds specified, they initially will see that still content, but in the background we actually trigger a regeneration of that page. So once a page has been regenerated, the cache gets invalidated and updated with that page. So now when a user requests it again, they will see the updated content. So with incremental static generation, we can show dynamic content by automatically revalidating the page every number of seconds. And although this is already a huge improvement to what we saw before, we can still run into some issues here because it's likely that our content actually doesn't update every number of seconds, which would mean that we're unnecessarily invalidating the page or invalidating the cache and regenerating the page every number of seconds, even though the content hasn't actually changed. Now, the best option here is to use on-demand incremental static regeneration. So with on-demand ISR, instead of regenerating on a certain interval, we can actually trigger a regeneration on a certain event. So instead of relying on the revalidate field here, we can manually revalidate pages in API routes based on incoming requests. For example, we can listen to an incoming webhook from our data provider that tells us whenever new data has been added. When we invoke the revalidate method, the page on the specified path automatically gets regenerated. Another huge benefit of using on-demand ISR instead of regular ISR is the fact that the newly generated page is automatically distributed throughout the entire edge network. With regular ISR, we only cache the response in the region where the user requested from. But with on-demand ISR, users from all over the world will always see cached content, and they will never see a still page. We also don't have to worry about unnecessarily invoking a serverless function every number of seconds if content hasn't been updated, making it a much cheaper pattern to use. All right, so on-demand ISR gives us all the performance benefits combined with a great developer experience. We don't have to worry about the high server costs anymore as long as we don't trigger a revalidation too often. Now, static generation is an amazing pattern that can be used for tons of use cases. We can have incredibly fast and dynamic websites, and we also have a website that's always online because there's always a cached version available. We also end up with way lower server costs, or costs in general, since we don't have to think about the server costs. But there are also tons of use cases where static rendering isn't the best way to go. For example, for highly dynamic, personalized pages. In that case, we want to use server-side rendering. So whereas the HTML was generated at build time using static rendering, with server-side rendering, we actually create it on every request. So this can be a great approach for pages that contain highly personalized data, or generally data that was within the request, maybe user cookie. It's also really good for pages that are vendor blocking, maybe based on authentication or authorization state. An example of a highly dynamic page is anything that requires a user cookie, for example, this dashboard. This dashboard is only shown when a user is authenticated, and it shows user-specific data. So in Next.js, you can server render a page using the getServerSide props method. And this method runs on every request, and the data that gets returned from this method is eventually passed to the generated HTML. So when a user again requests a page, the getServerSide props method runs, the page gets generated and sent to the client. The client can quickly render this HTML, and it again can send an additional request to hydrate all the components. Now, the generated pages are unique to every request, meaning that they aren't automatically cached by our CDN. Although this is the expected behavior, there's just more to take into consideration if you want to get a great performance for every request. So when we look at the network and main thread, it looks pretty similar to what we initially saw with static rendering. The first contentful panes is equal to the largest contentful panes, and we can easily avoid layout shifts as we're not dynamically rendering content. But when we're comparing static rendering to server rendering, you can see that the time to first byte can be very short when we statically render data, whereas it can be pretty long when we server render data, as we still have to generate the page on demand. Now, although server rendering is a great method when you want to render highly personalized data, there are just more to take into consideration to get a good performance. We might also run into higher server costs, which might be totally expected and worth it. But there are a few things that you can do as a developer to optimize your SSR performance. First, we have to make sure that the getStaticProps method doesn't run for too long, because the page generation won't start until this method has returned with data that gets passed to the page. Now, one thing to keep in mind is often also the cause of long getStaticProps execution is the time it takes to fetch data from your database. So if your serverless function is deployed in San Francisco, but your database is deployed in Tokyo, it can take a while to establish a connection and actually get this data from here. Now, instead, consider moving your database to the same region as your serverless function to ensure that your database queries can be a lot faster. Next, you might improve your performance a bit by adding caching headers to the responses. But if you find yourself doing that, your page might work even better if you used ISR. Because besides not having to manually take care of revalidation, the recomputed page will also be shared globally, as opposed to just one single region. ISR also ensures that your website's always online, and there's always a cached version available. Because with SSR, you're dependent on the availability of the region. Because if your Lambda is down, so is your website. But yeah, ISR doesn't allow you to use request-based data. So if you have a page that does require request-based data, SSR is still the way to go. Now, the last one is a bit harder to do as users, namely upgrading your hardware. So when you deploy to Vercel, we use serverless functions to server render your data. And although serverless functions come with so many benefits, there are some limitations to them. Now, a common one is the cold boot, and that's the time it takes to start the Lambda. Also, the slow connections to your database. It's also not great to have to call a serverless function all the way in, say, the US West Coast when you're located in Europe or in Asia. Now, at Vercel, we're currently exploring Edge SSR, which means that users can server render from all regions and experience a near-zero cold boot. Another huge benefit of Edge SSR is the fact that the Edge runtime also allows for HTTP streaming. With serverless functions, we had to generate the entire page before a good gets sent to the client, and then also download the entire bundle before hydration could start. But with Edge SSR, we can actually stream parts of the document as soon as they're ready, and also hydrate them granularly. So this means that users no longer have to see a blank screen for a long time, as the components will stream in one by one. Streaming SSR also enables React server components. Now, I know it's already been talked about a little bit, and I won't go into the nitty-gritty details of React server components, but the combination of Edge SSR with React server components allows us to have a beautiful hybrid between static and server. Because React server components allow you to partially render your React components on the server, which is especially useful for components that require or that use really large dependencies, because we no longer have to download them all the way on the client. For example, if we wanted to show this landing page again, but this time we wanted to show region-specific listings to the user, maybe with a geolocation. Now, the vast majority is still static. It's just the listings that require request-based data. So instead of having to server render the entire page, we can now choose to only render the listings component server side, and the rest still client-side. So whereas we initially had to server render the entire page to get this behavior, we can now get the great performance benefits of static combined with the dynamic benefits of SSR. All right, well, we've just covered so many patterns to choose from, and I haven't even covered all of them. But knowing which patterns makes the most sense for your application can give you huge performance benefits. And with Vercel, you can opt into these techniques on a per-page basis, making it extremely easy to scale without running into any performance issues when your application grows. Static and server rendering both have their place in the world, and we're working on a future where we can create highly personalized pages with a great performance. The web is extremely powerful, and it's only getting better, especially with an edge-first approach to look forward to. Thank you so much for coming to my talk.
Hey, yes, keep it going for Lydia. Amazing job. All right, keep it going. I know it's late, but we still got energy. Please give it up. Please keep it going for all our keynote speakers. How awesome were those 3 talks? I mean, and we got a whole more 2 days of awesomeness, so get excited. All right. Before we continue the evening, let us also please give it up for the people making the magic happen behind the scenes. We got the Reactathon staff, we got the CalShake staff, we got the AV crew, and they are doing an amazing job. Please join me in thanking them. Awesome, awesome, awesome. So yes, and of course, Reactathon would not be happening here without the main organizer, the brains behind the whole operation, the whole shebang, the person putting the athon in Reactathon. So we are going to bring on the main organizer of Reactathon for a little casual chat now. So please join me in welcoming Benjamin Dunphy. Going. Oh my gosh.
So good.
3 dimensions, y'all. So excited to be here, as we all are, right? So thank you. And yeah, so how do you feel? I know how I feel. Great about being here at in-person events again. How do you feel about being back to the in-person lifestyle?
Yes. I mean, can you hear me? Yes. Okay. We get some of that, right? We don't lose some of that from the Zoom. No, it just feels absolutely incredible. I mean, this is why I do this, right? Bringing everyone together. I mean, for the past 2 years, we really lucked out with this happening in this period of history, because we have this amazing technology that kept us together for these last 2 years. But we were still apart. We're on Zooms. We're in Slack. We're not in person. And just seeing this come together just the way it is now, it's just corny, but it really warms my heart. It really, really is just something else to happen. And while it's a big undertaking to make this happen, and so many people, as you pointed out, make this really happen, it's just really exciting to see the video village back there, the speakers getting ready, conversations happening. It's just really great.
It takes a village to make a conference, right? So I'm really glad to be here. Thank you for having us. So we have a lot of excellent stuff coming up the next couple days, right? That's why we're here, for the excellence. So what are you particularly excited about that's coming up in the next couple days?
So for the past few years, we've been doing this thing called topic tables, where we set up a table and we put a topic on it. And it's managed by experts. So for the Redux topic table, for example, we'll have Mark Erickson, the maintainer of Redux, managing that. And we have a separate table for state management. So if you're not into Redux, then David Korshid, Eric Rasmussen will also be there. And so many others. Ryan's going to be managing the React Router table. Kent's going to be managing, I forget which one, but it's a really good one. So that's going to take place just right out there. So we did have some big feather banners, but supply chain issues. So we got little tiny topics on the little tables. So you got to put your binoculars on, but you'll find them. Just
look
for the folks.
To each other to talk about topics.
There we go.
Yeah.
Something like that.
And we're going to also have a table about managing the tables, about the topics, about the tables, about the management. No, just kidding. Cool. So yeah, everyone is going to be excited about those conversations, and we have just so much awesome content still to come the next couple days. You've seen it on the schedule. It's going to be exciting. We have so many great talks coming up. I'm excited about it. But you know, there's also other things happening in the world besides this awesome conference we find ourselves at. So what else have you been up to other than Reactathon recently?
Well, so events is kind of my thing. But there's, you know, I think the past 2 years really highlighted for us, like, how in-person events are really important and how remote events are not exactly events. There's so much more that happens besides the talks. When you're watching a live stream, yeah, you can connect, yeah, there's some interesting things you can do, but you don't really capture the dynamicism of the in-person connections. And so what I've been working on with a team of videographers and some hosts is we've been traveling to conferences around the world, and we've been getting really good like cinematography at the events. And we have a host who does like on-site interviews with various speakers. And so after that, we put that all together. We make like a 10-minute episode that shows off a little bit of the topics that the speakers are presenting with some visuals and et cetera. And I think actually, this is really boring me describing it. Why don't we just take a look?
Let's roll film,
Actually.
shall we? Who wants to watch the world premiere of an extra special video?
It's one of the hottest and most anticipated tech conferences in all of Europe. Since 2012, engineers the world over have congregated in Barcelona to learn from some of the brightest minds in the web community. But for 2019, the last in-person conference they held before a certain virus put a halt to it, the organizers at CodeGram decided to switch it up a bit, moving the conference to the beautiful town of CJ's. In this series, I get an inside look at some of the topics covered at this event through intimate conversations with speakers. My name is Swiss Teller, and this is Conference Insight. Web design, web animations, UX design. These are all vital components of our experience on the web. Without solid web design, you're sacrificing first impressions and trust in your brand. Without animation, you're missing the chance to tap into our natural instinct to notice and be interested in things that move. And without a solid user experience, well, your users won't be able to understand your app or service at all. But what is good web design? And how do you balance that with a good user experience? It's not as easy as you think, especially when the industry has so many accepted patterns and practices that tend to make things a little stale. If I could talk to anyone about these topics, without question, it would be Sarah Drasner. She's one of the best web engineers in the world and has design chops to boot. She's now director of web engineering at Google. And at the time of our discussion, she was VP of developer experience at Netlify.
Sometimes I feel like we're in a bit of a rut where people have stopped exploring, and there's a little bit of this, like, every site starts to feel the same.
Yes. That famous tweet, which of the two possible websites are we designing?
Yeah, exactly. I think I even show that tweet in it.
Yeah.
And I think that that's kind of a shame, because the web is possible of so much more than marketing sites and forms. And yet I think that that's what we do most of the time. So kind of exploring some of these concepts of how do we push the boundaries of what is acceptable, of what we know how to do, about what's memorable to people, because if your site looks the same as every other site, people aren't going to remember it anyway.
It just all looks the same.
Yeah,
it's the blue Google and the white Google.
Yeah, exactly.
Sarah makes a good point. Most websites today look the same. And in most instances, this is not born out of laziness, a lack of imagination, or even a limitation of our own developer tools. Rather, we do it to set clear expectations for our users, to reduce the user's cognitive load. Cognitive load is a theory developed in the 1980s by John Sweller and made popular among web designers when Steve Krug published his seminal work, Don't Make Me Think. In it, Krug argues that the more questions you introduce for users in your interface, the less effective your web experience will be for your users. So if this reduction in cognitive load produces cookie-cutter websites, how exactly can we move forward in web design and get us out of this rut? Sarah provides us with a few possibilities in her talk.
But what if our websites weren't just available and responsive in 2D, but 3D as well? What if the browser offered some basic hooks that we could hook into to create experiences with ease, just like Flexbox and media queries? So let's say you're browsing on your phone and you decide that you want to check it out in like a simple VR headset. One of these are like $30, I think. They're not too expensive, and there are some cardboard ones that are even cheaper. And at first, you know, the kind of first level of this is you're just kind of looking around at things, right? And you're able to select. But the second level of this is that it detects the VR headset and things are allowed to fall away. And all of a sudden you have a different experience, which for something like this actually gives us a ton more information about that place if you're trying to figure it out. So I made this demo using some of the techniques that we just talked about here with Nuxt page transitions, as well as Three.js, as a basic proposal of what this could look like. And we're going to talk a little bit more about the spec in a second too. So you can see if I do go to a travel site, I can use something like this to actually look around. And on the page itself, we're going to capture the coordinates of the mouse or the head as it moves. And we'll update some transforms as well as a perspective origin on those DOM elements. But we're also going to create sphere buffer geometry. So basically in Three.js, we're going to create a big circle. We're going to apply a texture that's around the inside of that circle and add it to the scene. And then we'll move the camera around in Three.js. So basically we're going to say, okay, where in the circle is the center? And now I'm going to pan around the center of that circle to look around this scene. But what's important here is not how it was made today with web technologies that exist. It's more exciting to think about what could be in the future. So if I want to take this square and I want to make it a circle, you probably all know how to do that with border radius. But what if we had something like a media query for VR, where I could just apply material grass, and that existed as a browser spec? A lot of times if you're working with Three.js, you're applying material env maps, reflectivity. What if you could apply those with, you know, CSS the way that you would with a filter or something? So this is a leaked screenshot of the Chrome DevTools, what might be on the horizon for 3D responsive coming out in the future. If you don't know Josh Carpenter, you should check him out and follow him on Twitter. He posts some really amazing stuff about what they're working on and what the future might hold. And here's a detail view of that and what that might look like. So here's a piece of those Chrome DevTools where you might be able to manipulate a chair in space. And what would happen is if you're on a screen, it would either be flat or you would be able to move around it slightly. But if you had the capability for VR, you could add a media query and change things and move things around in that space as well. So they give you some hooks for that.
Oh man, how nice is it to have Sarah here, sort of, right? Oh, it's great, because Sarah's the best, and it feels like she's here with us today a little bit. We miss you, Sarah. And also, how great was Swizz as the interviewer, host? Huh? And oh my gosh, celebrity front row. Look at this. So we are graced by the amazing Swizzette Teller, host of the video and part of this project. So yeah.
It's a lot of fun. Swizz, you sound a little different in that narration, though.
Yeah, it turns out that acting is really hard, even if you're just acting yourself. So Ben had to do the voiceover.
Yes, so sorry for the abrupt ending. We wanted this to be a premiere, but this is actually a screening, so not even color corrected, you know. When you're organizing a conference, your time is stretched a little thin. So, so do we like that? What do we think? Should I do some more episodes? If you've seen some cameras around this space, we actually have some episodes here taking place from this conference. We're going to have 4 episodes. So we're going to have Lee Robinson, Lydia Hallie, Jen Creighton, and, oh my God, who's the last one? Brain Farts.
Sweet. No.
Swix, yes.
Yeah. Hey.
Swix, how could I forget Swix?
Speak about
There he is.
cameos.
Yeah. So our lovely host for this series is going to be the one and only Eve Porcello. So she's conducting interviews with these folks, and I hope you can look forward to some of these episodes in the future.
Yes, so everyone stay tuned. You're going to be maybe making some photobomb cameos in the background of some of these things, if you don't watch out. So yeah, thank you again so much for this great interview, and we'll be hearing more from Swiss tomorrow, too. Alrighty, well, we're getting towards our last exciting thing of the day, right? The topic tables. So please join me in thanking once again Ben for putting this all together. And huge thank you to the videography team, doing an awesome job. Our last moment together today is going to not be here with me yakking at you from the stage. It is going to be back in the sponsor area where, as Ben mentioned, we're going to have topic tables, lots of different topics. We got React Day 2, we got React Native, we got all kinds of stuff. Look out for the little signs on the tables for the different topics, again, in the sponsors area. And if you would like, you can also just hang out with our awesome sponsors at their awesome booths and chat with them. So yeah, enjoy the evening festivities, great conversations. We got drinks, non-alcoholic, or whatever you want. And we also are going to be back here at 9 a.m. for more awesome talks. So with that, I will bid you all see you in 5 minutes out there. And also, please join me. One more round of applause for all our speakers today. Hey, yeah. Thank you all so much. See you later. See you tomorrow.
Thank you.